Good morning and welcome everyone. This is Barb Miller-Webb. I'd like to thank you for attending this week's webinar on reverse engineering. This webinar is going to cover how to start with existing objects, create new products, and alter old ones without having to design from scratch within your Geomagic Capture, which is a family of integrated software for professional scan-based design. Geomagic Capture combines history-based CAD along with 3D scan data processing, so you can create feature-based, editable, solid models that are compatible really with your existing CAD software you guys are using today. So let's watch this webinar to see how to design a new part from the surface of a scan and show the multiple print process to refine the part for desktop scan. In addition, we're going to introduce the concept of technology consumption gap. And by the way, next week's session is going to cover plant and process design, so we encourage you to attend. Today's presenter is Kevin Marchant. He's from our D3 Tech team in Kansas City. And as we go along, you may have some questions in the session. So at the end, we'll provide a means to get you those questions answered. Just a brief word, if I could, about D3. D3 is the top integrator of Autodesk manufacturing solutions, offering a wide range of services to help our customers design better and manufacture better. So some of the services that we offer include, number one, training, and that could be public, private, individual, or corporate training plans that we offer. We offer support. That could be through via phone, chat, or email. And of course, we have mentoring, either one-on-one or general Q&A, all the way to project consulting. Of course, implementation includes best practices, consulting, and lastly, automation of engineering, design, and sales. So without further ado, I'd like to go ahead and introduce Kevin Marchant and let him start this session.
Thanks, Barb, for that great introduction. I'll switch over to my screen here. And our webinar today will be based again around reverse engineering. Barb introduced a theory called consumption gap. The book Complexity Avalanche, shown here, defines the consumption gap as the difference between the potential value a product could provide to an end user compared to the value that is actually being provided today. In the book, J.B. Wood identifies the curve shown here as the addition of features and complexity seen in technology products in the last several years. This technology not only relates our topic of engineering software and hardware that we will be discussing here today, but also industries such as cell phones, automobiles, and even televisions today. The lower curve shown here shows the trend of end users to consume the features being offered without assistance. This is where D3 can help to maximize value that you would be receiving from the software you currently own today. So D3's goal today is to help minimize the consumption gap by showing you a couple workflows and tools that we believe are currently being underutilized or, in all actuality, not being used at all. Topics we'll be covering today is capturing product geometry, creating usable CAD neutral geometry, and using that geometry in your said design. And the tools we're going to be using today is a Geomagic Capture camera shown here in the images that you can see. Hopefully now you can see my screen. There's the graphs that I was talking about. Sorry about that. So we can see the graph on the top there again shows the complexity of the software. The graph on the bottom shows how users are actually adapting that information, and the gap in between where, again, D3 can come in and help you maximize that information. The hardware that we're going to be looking at today, or we're using today, is that Geomagic Capture camera that we can see there in the upper left and the bottom pictures as well. And the plate that we're going to be scanning is a demo plate that we've got, and we're just going to be basically utilizing these three mounting positions for our design, mounting plate of some kind out there. So we're wanting to capture this information out here. We can see the grid pattern that shows when the camera is ready out there on that image itself. And you'll notice that the part that we've got is a very flat gray in color. Now, a lot of machine parts we may be scanning may be highly reflective. One thing to note is if it is a highly reflective material, we want to coat that. We here at D3 use a weld check. It's a spray material, extremely thin layer, basically makes the object a very flat, almost white in color that works extremely well for capturing fine detail in these guys. So with that, I'm going to jump over to the Geomagic software itself, and this is what we're seeing here today that we're going to be looking at for the majority. I'm also going to use a little bit of Inventor as well once we get in here. And so what we're going to do is we're going to come out here and we're going to connect. And so both the software and the scanner itself very CAD agnostic, meaning the software, Geomagic Design X, can connect to multiple different kinds of scanners, including Faro that's not listed here. But we're using that, again, that Geomagic Capture camera. There's our little kind of preview of that. And then what I'm going to do is I'm going to turn on my webcam here, and there we go. And so you can see that grid pattern that you saw in the pictures. And I just like to show this first couple times because when I come out here and scan this, you'll see what's called is the Hdr pattern. It's going to go across with multiple patterns, and you can see how it starts out broad and refined. You can also tell that I don't have the room that I'm in really dark or any special lights hanging up. I've literally just got my overhead lights in my office here. And there's our geometry. And so what I'm going to do is I'm just going to reach out here, and I'm going to rotate this part, keeping it centered with that dark grid pattern right there, which we can also see on the part right here. So it's a lot of feedback telling us we're doing this the right way. I'm going to take another scan here. We'll see that come across there, and you can see it doesn't take too long, and we can already start to see on our screen a lot of geometry being captured out there. Being that we only have our 25 to 30 minute time frame out here today, we're not going to be able to go through this step by step by step. So this is going to be more a la cooking show. I'm going to start off with a few steps. Let me get this one more turn. I'm going to try to get this a big change. We can see how these are automatically starting to line up our scans because they're close enough the software can tell what geometry is what. I'm taking a bigger jump than I normally would to try to show you one that doesn't line up like that. But back to the cooking show. So I've got several files created, so we're going to be taking some jumps in the workflow just to get everybody an idea of what working with a scanner is like. And so you can see, again, we're capturing geometry very quickly, very cleanly, and I'm not requiring a whole lot of space both on my desk, as you can see, with the pictures plus the webcam feed there in there. So the last one we get, and if it doesn't throw it off, which is great, there we go. So that one did. So I'm going to turn off my webcam now because I'm done scanning. And so I'm simply going to come over here and I'm going to tell it, hey, I'm done. And one great thing about Geomagic is it gives us helpful hints. It says, hey, this is what you should be doing next. Is this what you want to do? And yes. So I can come in here and I see I've got the scan that doesn't line up with my others. So we're just going to real quickly come out here, a couple steps because we don't need to clean anything up, and hold to that guy, and I'm going to move this last guy out here, turn this guy over, turn this guy over, open. These two guys aren't fluid enough, so actually let me turn that one back on. Let me reference this guy. We just want to be able to see the same geometry in both. So if I orientate these to where they're about the same, I can zoom up in here. And we can see we've got the top of that guy. I'm going to come down, pick about the same point down here. And in the window on the left, you can see it's starting to line up my points. I'm going to go here and here. Let's try to get pretty close to the center on that guy. And we can see all of a sudden he's laid over and he's real close to where he should be. And we say, yep, done with those guys. And then I would move on. I'd jump out here and I'd say, yep, that's pretty close. I can still see that, I've got some surfaces off a little bit out here, and that's fine because I'm simply going to come out. I'm going to reference one. I'm going to let it move all three of those. I'm going to tell it, hey, I know you only need to move some small increments. And I'm going to push those guys together. So the software has come out, and the software itself has looked at how its points are lined up, and it's done some very fine tuning. And what we get is, if you recall from the separate images, separate scans, they were different colors. And so now we've got this great overlap, wash of color speckles in here, and that's really what we want to see. The more color interlaces, the better off we are at surfaces fighting for that same space, and that's exactly what we want. And we can adjust how tight and fit those are right there. And so I'm just going to say OK, and this process shouldn't take too long with that few scans. Out here, and then after that I'm going to be just opening files, taking some bigger jumps in the workflow, because we've got some big holes in here, and that's fine. Because again, we're just really focusing on the domes that we want, these domes and the cones out here. So there's our surface of that part, and you can see how very quickly I was able to go in there and capture this geometry. We can even see the texture from the plastic in there that our part's physically made of. And again, if I spent more time with more scans, then I would fill in these holes. I can also use tools within the software itself to come back and fill in those holes. So we're all finished up with that process. So now we can pull that out. And that's pretty cool, because that took, less than 10 minutes to pull that geometry out of there. So the next thing we would do is we would come out here to, again, I've got some recent files cooked up here. And we already looked at the ones that are merged, and I'm not going to save these. This is the kind of the start of what I did, and I took a few more scans. We've got holes in different spots because it was a different base set of scans, but my domes are a little bit more secure, a little bit more solid in their surface out here. After we get our surfacing done out here, we get all those meshes merged, then we can come out. I think I just actually clicked on the wrong thing there, and we're going to go back a step. Yep, there's a rough merge together with more scans. So I'm going to come in here with views. So after we get the surface created, then we want to pull this up so we're looking at it flat. And also with this one comes regions. So we pull it up and we create planes, reference planes. So now if you are one of those designers out there that uses a CAD tool, used to looking at things, front view, back view, side views, tops, bottoms, all those fun views that we're used to being able to click through and get a good idea of what we're working with. On top of that, we came in and we did an action, and that is the views creation is a wizard. Again, so we're just picking on surfaces that we know to be flat, or we can create work features to pull planes in between two surfaces through axes, axes, however you particular say that word, depending on where you're at and how you're raised, to pull those references in there, and then we just pick geometry to go with it. And through that process, we also create what's called regions. Not the view, but it's a different command out there. But our regions are what give us these shapes: cones, spheres, another sphere, there's our sphere. So we just verified that, yes, we've got spherical shapes out there. We've got planes. We know that to be one big flat surface, so the plane's right. We've got cylinders out here, cones out there. And this is just how the software interprets the data for us. And so what that allows us to do is to verify, say, yes, that shape is what that needs to be. I can go in and override through workflows and say, you know what, I look at this and that is so close to being a cylinder versus what it thinks is a cone, because that may just have just microns of slope to it, which, as most of us in the manufacturing industry know, if we're molding something, we have to have a relief angle in there. So if I need to, I can go through a process and I can tell my software that, no, this is in fact a sphere, or not a sphere, a cylinder out there, and it will relabel that. Same thing with these guys out here, and we can see we've got planes, big curved wall that's interpreting that as part of a cylinder. Out there we've got another plane, so we're seeing geometry that we expect to see from our scan. So the next thing we're going to do, is go through a process to tell Geomagic, hey, go through my scan data and find everything that makes a physical part, a three-dimensional object within this model. And so if I come out here, I've got some solids out here. And so this takes just a little bit longer to load because now I've got geometry in there. And through that process, what we do is we lay a surface over the top of these regions. And when that surface comes in, that's what helps it define a closed surface, a continual surface, all those triangles merging together. Well, then it picks through and says, hey, this is a solid part, this is a solid part that we can use out there. What that also does for us is that gives us a graph, and I can actually turn this graph on anytime I'm working with my part, and all it's doing is it's comparing what either I have defined, because I can also go in, instead of saying automatically find my surfaces, I can put sketches in there, and I can do things similar to offset sketches and pulling geometry. I can project that geometry. Anybody familiar with the major design packages all have similar tools. This has those tools. It just works in a slightly different manner, but they're there to draw a circle, and then we can extrude that from this surface to that surface. And again, it's just picking that cloud scan data that we're picking the to and from. Just on this one, we went ahead and let it automatically do that because we know we've got good clean geometry in there. So what that does is we look at this and it tells us our deviation, our surface deviation. And so what I care about again is our mounting surfaces out here, and those all worked very well. I've got nice green, I've got no deviation in there. And again, over here in the corner where we had some bad scan data out here, our surface laid in there over our mesh, and we can see that it doesn't really match. So at that time, I would want to go back in my process and refine that information more. That would make my life easier if this is what I cared about. But today, it's not. Today, all I care about is these guys here. So what I can do, if I come out here and I can turn off those surfaces, there's my solid bodies. And I see that I've got a little bit of deviation on the height of where it terminated the height of my cone and my cylinder. And again, if I want to, I can come in and I could redefine that geometry, make that fit a little bit better, depending on the tolerance that I need for my design in my part out here. So from here, I say, you know what, I'm happy with those three solids. That's exactly what I was looking for this part that I'm creating. So I'm going to come out here to my live transform, and right here we can see again that CAD agnostic Geomagic saying, hey, I can work with Siemens and Creo and AutoCAD and Inventor and Solid Edge and SolidWorks and all those fun things out there. Now I would normally hit this Inventor. This takes, depending on what geometry you have going on, it's fun to watch the first couple times, we'll say. What it does is it literally goes through your native software. So this would boot my Inventor, would start a new part, and it would start putting out sketches. And what you end up with is a part that looks like this. And this I have not touched. This is as Geomagic push it out to Inventor. So I can see all those surfaces. Here's my spheres. I can look at that. There's my sketch underneath that sphere that define that geometry. I can easily manipulate this data. So if I'm capturing geometry that I want to change, that I'm going to remanufacture for my reverse engineering, I'm going to pull it apart, I'm going to change it, I need this part, but I need this part, and it needs to be this way or that way, or here's the improvement we're doing for this part, all of those kinds of things. I have that native geometry that I can now manipulate in my CAD software. We're using Inventor because that's what we like out here. And it works extremely well with it. And I just have to remember which software I'm in, so I remember to rotate and manipulate differently my views. And so out here I've got this surface model that if I come up here and I can turn off the visibilities of those guys, a couple quick cuts to clean that up. There are my three components that I care about. Those are the ones I want to use to start creating my part that's going to mount to these. It's going to utilize these locations as an index for some reason. So now I've got to put my geometry on there. I've got to start my part. So I'm simply going to come out here. I'm just going to throw a box out here, and I just want to make sure this box covers everything that I've got. I'm going to come out. I'm going to make sure this is a new solid. I can see that I incorporate all of that information. So we'll call this up here. We'll give this a cool 2 inches. And you may have noticed it came in as a metric part. That's how my scanner brings things in. And so now I've got this box out here. And I want to carry over, pardon me, the information of those 3 locating pins or spheres, however you want to call them out there. And so I'm going to come out here. First I would come in and I would do a save as, create this new part, so I keep that geometry separate out here. Today I'm okay with that. It didn't take me long to create it. So I'm going to come in, I'm going to combine. Use this combine tool. I'm going to come out, select my base, and then my tool bodies are going to be every other solid in here. And I just want to make sure that I come in and I cut these out. Say apply. And now I've captured this geometry that I can now use in my design, pardon me, whatever that design is, for my purposes. So I hope that the time that you've spent with us today has been helpful in showing you the use of not only software, but some of the hardware that's out there and available for us. Again, this was the 3D Systems Capture blue light scanner and the Geomagic Design X software, pushing to our native software. In this case, we chose Inventor, and we used that geometry to start creating our part, the part that we wanted to come up with, the part that we wanted to use out there for us. And so I'm going to flip this back to Barb as long as she's ready for me out there.
I am.
All right, here you go.
Okay, and I didn't see any questions out there. So did anyone have any questions from that presentation? And maybe while you're thinking about that, what I'd like to do is certainly thank Kevin for the presentation he just did, and maybe provide a couple of brief polling questions if I could for just a second. So I have the first polling question, which is whether or not this webinar session was a good use of your time. And if everyone could just go ahead and accept. And then I've got a second polling question, and that question is, would you like a D3 representative to contact you specifically regarding any questions or comments? So if everyone could either answer yes or no on that. Okay. Thank you so much. And then did anyone have any other questions in reference to the reverse engineering that we just discussed before we end today? And I don't see any questions out there, so okay. Well, thank you all very much for your time and attendance today, and we look forward to seeing you at the next D3 Virtual University, which is going to be Plant and Plant and Process Design on September the 15th. Thanks, and have a great